So this is the final toolkit for the science and engineering practices. Thank you for joining me on this journey through the practices. I hope that they have provided you some helpful tips on how to easily modify your existing materials towards alignment to the K-12 science framework. As scientists, we are accustomed to trying to identify isolated cause and effect while keeping a holistic view. Since each practice melds with the others, the last two practices are no different. One needs to be able to consider validity of information and distinguish evidence from inference, substantiated data from substantiated belief, impartiality from bias, accuracy from precision, and so forth, and the interplay of each in order to make sustainable decisions. We can look at Science and Engineering Practice 7, Engaging in Argument from Evidence, and 8, Obtaining, Evaluating, and Communicating Information to assist us in developing these skills in our students. One aspect of science and engineering that intrigues me the most is that we can count on the fact that as more evidence is collected, the more we learn about natural phenomena, and the more we question what we currently know. Allowing students the time to explore the evidence behind scientific information and the rationale for design solutions assists them in identifying the strengths and weaknesses of both. If I went to an elementary classroom in my school district and stated that chopsticks are superior utensils to forks, I would bet that most students would disagree with me. Well, hopefully, if the practices are being taught in the classroom, they would first ask me to clarify what I meant by superior, and then disagree with me. We could then discuss how we could distinguish opinion from evidence, come up with a valid experiment to test our hypothesis, collect data, and evaluate results. If none of the test subjects had prior experience using chopsticks, the evidence would most likely support the students' opinions. But if the test subjects were well versed with chopsticks use, the evidence would most likely support my original conclusion. The focus here is not who's right or who's wrong, but what the evidence supports and why. By the time students leave 5th grade, they should be able to respectfully engage in debate and have a firm understanding of the distinction between opinion and evidence. In middle school, this practice evolves to comparing and critiquing evidence from multiple perspectives on the same topic, and in high school, to critiquing and communicating evidence from multiple perspectives and multiple topics. Science and Engineering Practice 7, Engaging in Argument from Evidence, is another practice that requires a constructive response. In this practice, students must support and/or refute a given statement and cite evidence to lend credibility to their stance. In the early grades, students can begin to distinguish evidence from opinion, develop the skills necessary for active listening, and the ability to construct an argument with evidence to support the claim. In this grade 3 through 5 example, a student must be able to identify the evidence provided in order to support their claim. The depth of knowledge needed to answer this question is at level 3 for 6th through 8th graders. A complete answer to this question would include reference to the hamburger being comprised of fat and protein, and that these organic compounds are a source of energy for us. Here's a sample lesson providing students with an opportunity to engage in arguing from evidence. Obtaining, evaluating, and communicating information clearly and persuasively are the focus of Science and Engineering Practice 8. Students need to learn the language of science and engineering, use this language appropriately in written and oral form, and present evidence persuasively to others. Opportunities to collaborate and communicate with one's peers are essential to developing proficiency in this practice. Shown in this figure is the grade level progressions for Science and Engineering Practice 8. Presentations, research, critiques of passages, and reports all fall under Science and Engineering Practice 8, Obtaining, Evaluating, and Communicating Information. Science and engineering education needs to develop students' abilities to read and produce domain-specific text. Practice developing domain-specific understanding begins as soon as a student begins to speak the language of science. At the K through 2 level, basic scientific vocabulary is introduced and used in reading, writing, and speaking. In grades 3 through 5, students begin to combine information in written text with that contained in corresponding tables, diagrams, and/or charts, and to develop explanations from their observations or conclusions. As scientific understanding increases, so should the student's ability to evaluate, communicate, critique, and synthesize the combined information they have gathered. Lastly, here is another classroom lesson exemplar to help you encourage your students to obtain, evaluate, and communicate scientific information.